Hey everyone. In today's video, we're going to take a look at function notation, specifically when you have an input for a function, being able to solve for the output. Okay, so here's your general function notation here. It's very similar to if this was, say, like a y equals 2x plus 1. That would be a linear function. Okay, it's just replacing our y with an f of x. It kind of names our function and gives it a little bit more of a, a function, or it makes it more specific. Okay, so here you can see that the number or whatever is inside is going to be our input, and that's our independent variable. Okay, and then our dependent variable is this entire f of x. Our entire function ends up being our dependent variable. So what we input clearly is going to affect the output of our function. Okay, so let's take a look at a couple of examples here. Alright, so evaluating for function notation. In this case, we are plugging in the input x value, and we're solving for our output, which is our f of x value. Okay, so here I gave us the function f of x equals 3x squared plus 4. We have a quadratic function. We can tell that because it's to the second power. Alright, and I am asking for f of negative 2. So as you can see, what I've done here is, if you're given a function and the input of negative 2, I'm going to plug in negative 2 wherever I have our independent variable, in this case our x. Okay, and then we would go ahead and solve this. So f of negative 2 is equal to, order of operations here, we do negative 2 squared, which is negative 2 times negative 2, which ends up being a positive 4. You have to be careful with that. Okay, so we get 3 times 4 plus 4. Gives me 12 plus 4, which gives me 16. Okay, so f of negative 2 would give me 16. And I'm going to write my final answer in function notation so you can see both the input and the output. Input of negative 2, output of 16. Okay, let's take a look at another example. Okay, here we have our standard linear function. This one's slope-intercept form, 2x plus 1. X, again, is our input, or our independent variable. And here we have three different inputs, negative 3, 2, and 0. Okay, so again, the f is telling us to use the f of x function, right? And then we are inputting whatever value is here. So in this case, it is negative 3. So in this one, I would do 2 times negative 3 plus 1. Here I would do 2 times 2 plus 1, and here I would do 2 times 0 plus 1. So you can see the input here is changing for each of our questions. Okay, so here I get negative 6 plus 1 is negative 5, so f of negative 3 is going to give me negative 5. F of 2 is going to give me 2 times 2, 4, plus 1, which gives me 5. And then I have 2 times 0 plus 1. Okay, so f of 0 is going to give me positive 1. Okay, so that would be how you would evaluate each of these for a separate input. All right, so that's kind of like your basic idea here for function notation. Some of the following videos will go more into detail on some different examples, looking at some different functions, and also looking at graphs of functions.